Okay, so today we're going to solve 1089 duplicate zeros. Given a fixed length integer array, duplicate each occurrence of zero, shifting the remaining elements to the right. Okay, so that's fine. Every time we see a zero, we write it 2 times in the new array. And yeah, at the end of it, we'll need an array which will be of size this plus the number of zeros. And yeah, that's it. You can just return it. Note that the elements beyond the length of the original array are not returned. Okay, do the above modifications to the so this is the catch here. So if this was not in place, you could just create an array, count the number of zeros in this, so that array would be size of this plus the number of zeros, and then you can just copy every time you see a zero, you write it twice, otherwise you write it once. So that's easy. Now to do in place, right? So let's say for this example, I have to do it in place. So now the catch here is that I can't use another array. So if I had another array, it would look something like this, right? And then I could just go from the start and keep on replacing the values. So since I can't do that, let's have 2 pointers. One which will be I and one which will be j, and let them point to the end. So here we have 1, 2, 3, 4, 5, 6, 7, 8. So I will be 7, j will be 10, right? And this basically is pointing to this array itself. It's just for visually I'm writing it this way. So if that's not a valid index, I won't write it and I'll do j minus minus. So now my j will become 9, right? And I see that it's not a valid index. And since it's a 0, right? I'm going to check again if it's a valid index. Since it's not. So basically, if it was 0, I would have written here 0, 0 and moved here, right? And then I check 5, which is also out, so I can't write 5. I move on, I move on. So basically, every time I'm going to check the index of j, and if that index j is outside, I won't write it. Otherwise, I'll write it. Okay, so I think this is fairly easy. I just need to go over, count the number of zeros. Once I have that, I can use that to create this imaginary array, which will be a pointer to this. And if that index is outside the array, I just skip it. I do j minus minus. If it's inside, I'll just copy the values. Checking if it's 0, I write it twice. So yeah, okay, so let's say for int x in array, if my x is equal to 0, I'll have counter which will count the counters 0, 0, zeros plus plus. Okay. Once I have the count of zeros, right, my int I will be pointing to array.length minus 1. Let's have another j, which is pointing to the same array, but it has zeros as well. So my I is 7, j is 10. Okay, until when I'm going to do this? Till my I is less than j, because anytime my j overrides it or reaches the same value, after that point my I and j are going to be the same. So if I had some, yes, okay, so while I is less than j, what I'm going to do is, okay, let's have a function that should take care of the boundaries and replacing the values. So let's say ij array, it's going to need 3 values. And I'm going to also check if my array of I is equal to 0. I'm going to do this again, right? And once I replace, I'm going to do j minus minus. And at the end of it, I can do just I minus minus, right? What is this function going to do? It's going to replace the values of these 2 indexes, given that my j is valid. So if j is valid, let's check that. Then only I'm going to do this. What I'm going to do is I'm going to replace array of j with array of I, right? And I'm going to do j minus minus. But since I'm doing that above, I don't think I need to do this. So yeah, you just replace the values. That's it. Okay, so what I'm doing here, just counting the zeros. Once I have the zeros, I have a pointer to the valid index here and the imaginary if it was here. And once I have this, I'm going to check if j was a valid index, I would have replaced it. So I call a replace. If it's valid, I replace it. Otherwise, I do j minus minus. And if it was 0, I would have put in 2 zeros here, right? So it would have been 0, 0. So yeah, this looks good. Okay, let's comment these. Yeah, okay, it's passing. Let's submit. Oh, awesome. So let's discuss the time and space complexities here. In terms of time, we're going over this O of n, and then I'm going to go again, and max is going to be O of n. So time is O of n, like you go over twice, so it's 2 pass, but still it's O of n, and space would be O of 1 since I'm not using any space. Yeah, that's it. Yeah, so thank you.